capital of South China. It's the third largest city in China with a population more than 10 million. Zhongshan Ophthalmic Center, or JOC, has two locations in the city central. Zhongshan Ophthalmic Center is the largest eye institute in China. JOC has four components: the State Key Lab of Ophthalmology, the hospital, the Department of Preventive Ophthalmology, and the Department of Ophthalmology and Optometry. The total space of JOC is over 100,000 square meters, with a bed more than 200. It has a total staff more than 1,500. We have more than 1 million outpatients visiting annually and more than 80,000 surgeries per year. Zhongshan Ophthalmic Center has ranked #1 in China for more than 10 years. Zhongshan Ophthalmic Center has very good publications in top-ranked and peer-reviewed journals.
Myopia from age 5 to 18 is estimated to reach 150 million or even more in China. The main cause is early education and over-educated. After strong recommendation by many doctors and public health professionals for many years, 1 month ago, the China government announced that all commercial tutoring classes after school must stop. This order has caused a big shock in many national tutoring companies who are listed in the New York Stock Exchange. Their stock prices are dropped dramatically. I believe that this will significantly decrease the myopia incidence in China after about 10 years. Prevention of children myopia in China include outdoor activities, special spectacles, OK lenses, drugs, and others. OK lens play the most important role in children myopia control in China. Even OK lens is quite expensive and has limitations such as age over 8 and myopia under 6 diopter. OK lens sales are still increasing annually in China. OK lens is introduced to China in 1998 by its advantage of nowhere mode at daytime and market unlimited promotion. OK lens sales increased dramatically within a short time and reached over 200,000 pieces in year of 2000. Because of less regulation and limited contact lens professionals, serious corneal inflammation are reported nationwide after wearing OK lens. The national government stopped OK lens practice. It restarted only in hospital and clinics after year 2002. Domestic OK lens is released in year 2016. OK lens sales are very strong recently in China. It's more than 1.2 million pieces in year of 2020 and is estimated to reach 2 million pieces in this year. OK lens has started at our eye center since 1998. The wearing age are from 5 to 40. Our mode is doctor-based service and has very good follow-up. We have annual patients more than 15,000 with about 3,000 new users per year. We made more than 30,000 pieces in year of 2020. We are leading state hospitals in China. In comparison with the eye hospital system, which is the largest eye service group in China with more than 200 eye hospitals, Its total wearing is about 100,000 pieces in 2020. In our hospital, the main reason for OK lens wearing is myopia control. The peak age is 8 to 15. The other reasons for OK lens wearing are job and army requirement. A few is for lifestyle. The quality control of OK lens in our hospital is by the doctor-based communication, standard fitting procedures, quality control of lenses, and patient education. Doctor-patient communication makes the patient and parents in realistic expectation, allow doctor to choose right candidates, and emphasize the importance of follow-up. Lens fitting procedures are very important, such as all brand whole line diagnostic lenses, on-site wearing testing, and fitting evaluation. Each order the lens is carefully checked upon arrival by means of its curve, power, and surface. We also have very good program of video and booklet for patient education. We carry out many national and local research grants for myopia control by examining and screening in schools. Finally, I would like to thank my colleagues and technicians, my students and postdocs.
Thank you for the invitation from the conference committee. I'm Beidu from Tianjin Medical University Hospital. My topic is patient management and risk control of orthokeratology during the post-COVID-19 pandemic. Orthokeratology has been used for ametropia correction and myopia control in China for decades. In China, the data of the past 2 years shows that the myopia rate of children and adolescents is at an extremely high level, especially in the first half of 2020 when the COVID-19 epidemic started and got severe. The myopia rate among students in the first half of 2020 has increased by 11.7% compared with the year before. Data shows that prevention and control of myopia in China is in a grim situation at the present stage, especially during the outbreak. The frequency of the routine eye examinations for children has been delayed or cancelled. Outdoor activities time sharply reduced, while the visual load for near tasks increased, including online education program and electronic entertainment products. This phenomenon could cause students' vision decreased significantly in that special period, and parents were still resistant to the clinic or hospital due to kinds of reasons or considerations. Under such circumstances, a great deal of patients with the demands of orthokeratology fail to review on time. Thus, in order to provide better eye care services and patient management and risk control are particularly important to deal with the situation. In early 2020, at the height of the epidemic, this child with OK lens were developed sore eyes. He did not visit healthcare practitioners or contact ophthalmologists. He kept wearing the lens, although that pain lasted for 2 months. Corneal infiltration and increased secretion were shown in June 2020 follow-up visit. Doctor asked him to stop the lens wear and treat it with medications. After the intervention, corneal infiltration did not completely disappear, with still mainly existed in the top part of the cornea. He was required continued to stop wearing OK lens. The explosive growth in the number of children undergoing orthokeratology treatment is mainly based on the increase of parents' awareness and the information dissemination between parents. Besides, the rapid Deterioration of myopic refractive error increases parents' anxiety as well. It also prompts many parents who were hesitant about OK lens to make a quick decision. Thus, there are stronger and stronger willingness for outpatient patients to fit OK lens. Well, as the number of patients soars, so does the potential risk. In fact, patients and their parents require to have a comprehensive understanding of keratoconology fitting. Thus, they should have a stricter patient education and screening. In addition to ocular assessment, it would be better to make parents understand the meaning of myopia prevention and control as well, and the role of OK lens. In the meantime, health practitioners should also be aware of the location where parents live and follow up compliance. More importantly, possible risks should be fully informed during the communication, including, firstly, ask whether the children are in the boarding school because there are a growing number of students live in school. It involves the wearing, removing, lens cleaning, and care procedures. Secondly, whether the children are allergic constitution, such as allergic conjunctivitis. There was a complaint from parents about the OK treatment seeds due to the allergic conjunctivitis. Thirdly, children's sleep time. If the sleep time is insufficient in schools, the ideal wearing time could be guaranteed. Fourthly, the logistic timeline. Parents usually have an urgent demand while the logistic involves many uncertainties, especially the international logistics, probably more than expected. This contradiction is more likely to be highlighted during the pandemic control period. The waiting time might be doubled and the complaints would be generated. Some parents will even complain that logistics affect the prevention and control effect of their children's myopia and vent their emotions to the doctors. These need to be fully communicated before therapy. Lens fitting management is an important step. Many parents have already paid attention to the hygiene status of trial lens. In the period of pandemic prevention and control, eye hand may be the media. Therefore, it is necessary to strictly evaluate patients' health and disinfect trial lens. At present, the number of trial lens has been doubled in many places. Make sure disinfection after each use and recording trial wearers' information for the traceability. The solution used in the fitting process should be a small package, and the bottle should be disinfected with 75% alcohol after use. Reduce the multi-person touch of the bottle, and the repeated opening can reduce the risk of pollution. Try to avoid using a suction rod when removing the lens. If necessary, the patient should bring their own tools and use separately. In order to prevent cross-infection, we should guarantee that the dye strips, which are frequently used in trial lens evaluation, must be discarded after each person or each eye. One patient should use more than one strip when necessary. The fitting of OK lens requires closer supervision and smooth communication between doctors and the patient to solve problems and difficulties in time. On the one hand, it is the management of patient compliance, especially the follow-up visits and the lens change. They are very important for risk control. The health practitioners who are specialized in patient education department should supervise the patient follow-up, remind them when the date comes. For the patients who don't review the doctor shall send out the stop wearing notice and inform them orally or via WeChat. After the patient comes back to the hospital and sign that document, the doctor could evaluate the patient's risk and cease the following fitting service. A specialist should keep online in the WeChat group every day to solve patient's problem at any time. During the pandemic prevention and control period, patients are unwilling to come to the hospital or reduce the frequency of coming to the hospital. The service department could provide contactless distribution services of lens solutions and other products. In the whole procedure of lens fitting, especially under the normalizing pandemic prevention and control circumstance, when facing a significant increase in the number of patients, only when we manage and control risks in all steps can we better ensure safety and effectiveness. Thank you very much.
Hi, everyone. My name is Maria Liu. I'm from UC Berkeley School of Optometry. It's my great pleasure to be here today for this exciting conference. And the title of my presentation is Myopia Control OrthoK Designs. Are we there yet? So I'd like to start this OrthoK session by sharing with you some of the major challenges we currently face in the effort of designing OrthoK lenses optimized for myopia control. While we have improved understanding of school myopia in general, and excuse me, the fact that it's a controllable condition, the exact anti-myopia mechanisms of OrthoK lenses have not been fully understood. Is it the competing defocus, whether it's superimposed or spatially biased, delivering to the central and peripheral retina, or is the higher order aberration induced mostly to the central retina, or the fact that there is a beneficial behavioral modification provided by the lenses that's also serving as important anti-myopia component? And on top of that, if we really want to understand the dose-dependent relationship between the lens design and anti-myopia efficacy, we need to first have a reliable and standardized way of quantifying the anti-myopia dosage delivered on the cornea. With overnight OrthoK, it is what's imposed on the cornea that matters for patients' daytime vision, as well as the imposed defocus on the retina. And lastly, it's well known that OrthoK lenses lack of treatment specificity, in which the same lens design will not cause the same identical corneal changes on different patients. So with all of that, let's get started in looking at the mechanisms. The mechanisms for anti-myopia effective OrthoK lenses are likely multifactorial. And if we take a look at the topographical changes induced by OrthoK lenses on the right side, we can see there are two major components that are drastically different than the corneal flattening induced by refractive surgery. More specifically, in the central retina, even though we're seeing a significant corneal flattening, but that amount of corneal flattening is not uniform across the whole treatment area. And instead, only the corneal apex is being flattened the most, and with drastic undercorrection or relative steepening beyond that central 1 to 2 millimeter area. So this type of non-uniform corneal flattening introduces a lot of higher order aberration and a relative myopic defocus. On top of that, we also see this dramatic paracentral steepening induced by OrthoK lenses, which is also not present with refractive surgery. So is this the competing defocus, or the higher order aberration, or the complete freedom from any correction during the day combined with clear vision offered by OrthoK lenses, hence creating the optimal visual condition, promoting or encouraging outdoor activities, which also has been shown to be protective against myopia? Or how are these factors played together in creating the anti-myopia effect of OrthoK lenses? Until we have better understanding of which of the components serve as the primary drive for the anti-myopia effect and their potential modes of interactions, developing a dose dependent relationship will be nearly impossible. Hence, the scientific foundation for an anti-myopia optimized design is lacking. In addition to continuous effort in understanding the mechanisms of the condition or its treatment, it's also critical to develop a better understanding and also reliable and quantitative way in defining the myopia controlling dosage delivered on the cornea. More specifically, we need to know the size of the treatment area or the central flattening and how non-uniform it is, the asphericity of this central flattening, and how to quantify the non-uniformity in the central flattening. In terms of the pericentral steepening, we also need to know the location, how far away it is from the visual axis or pupil center, and the width of this pericentral steepening, as well as how much the magnitude of this pericentral steepening. All of these are likely important components in the exact anti-myopia dosage achieved with OrthoK lenses. And even with the central, the size of the treatment area, we can see if it's defined or quantified on the axial map versus on the tangential map, you have very different quantification of the size of the treatment area. So which map should be used for which variable, and why is that? Are all of the measurements comparable across different topographers? Are the algorithms used to calculate peripheral cornea being sufficiently validated? All of these are critical questions await answers prior to a solid foundation in the exploration of anti-myopia designs. Another important component in custom tailored design is to take a patient's pupil size into consideration, both regarding its impact on the visual performance by the OrthoK treatment and its interactions and the long-term effect in anti-myopia efficacy. So the next intuitive question to ask is what pupil size to use, the photopic, scotopic, or the mesopic? The measurement is more complicated with when OrthoK is combined with the low-dose atropine treatment, in which not only the baseline pupil size is impacted, but other components of pupil behavior is also affected. So what other components should be included in understanding pupils' reaction with OrthoK lenses? Lastly, as a key component of the whole myopia management testing battery, pupil size should be measured with more reliable devices such as ocular biometers, dynamic pupillometers, or ocular aberrometers. And the information from a corneal topographer, such as lighting accommodation and pupil image extraction algorithms, are not sufficiently validated or controlled, so the pupil size measurement from topographers are not nearly as reliable. As a higher order aberration is potentially an important mechanism for myopia control, an accurate and a quantitative understanding of how angle kappa can confound topographical analysis, and once it's corrected, its true impact on visual performance and the imposed defocus will also be necessary in customization of OrthoK lenses. As shown on the topographical map here, without correcting for angle kappa, when we're acquiring the images, we get the false impression that the lens is decentered. But instead, once angle kappa is corrected, the lens looks perfectly centered, referencing to the anatomical center of the cornea. Lastly, it is well known that OrthoK lacks treatment specificity, in which the same lens design induces dramatically different changes on individual eyes. As demonstrated on the topographical maps, here, each vertical pair is the same eye wearing two OrthoK lenses with a slight design difference. So you can see for all of the eyes wearing the same lenses, the induced topographical changes are drastically different. So how to improve OrthoK treatment specificity, hence its intended anti-myopia dosage, is also an integral part of the OrthoK design optimization. So in summary, effective and efficient design improvement of OrthoK lenses that aims at optimizing myopia control outcome requires the combined effort in better understanding of the mechanism and a systemic and standardized way of understanding the anti-myopia dosage, as well as improvement on the treatment specificity. While the lacking of the answers to many of the important questions do not prevent us from proactively engage in myopia control treatments, the awareness of those unknowns will continue to be the ultimate drive for design improvement. With that, thank you very much.
Hi everyone, my name is Dr. Sarah Singh and I'm an assistant clinical professor in the myopia control clinic at the UC Berkeley School of Optometry. And I'm excited to join you in this virtual format to talk about how we can optimize our topography settings for the most effective orthokeratology lens fit and troubleshooting. So I'm going to take a case-based approach to today's talk. So without further ado, let's jump in. So our initial case is a patient who presented for their first or initial OrthoK fitting. And we see here that the patient is a moderate myope with a moderate amount of width of roll corneal astigmatism. And that's represented both in their refraction as well as in the keratometry that was measured. And here is their topography. So we typically use the Medmont corneal topographer in our clinic. So here we're looking at axial power maps from the Medmont, where steeper points are represented by warmer colors and flatter points are represented by cooler colors. And so we can see from this baseline axial map that we have this nice figure 8 pattern in each eye, which is characteristic of, again, with the roll corneal toricity. So this patient was fit with lenses, and when they presented for the one-day follow-up, this was the topography that was collected after lenses were removed. So now we're looking at tangential power maps in each eye. And the student that I was working with on this case was concerned about bilateral temporal decentration of the patient's lenses. So that despite having good vision and an ideal fit upon presentation, both lenses appear to be shifted temporally. And at first glance, that does appear to be the case. So we see that these black dots here are marking the visual axis. And if we were to measure where we think the kind of geometric center of this bullseye pattern would be, it's nearly 1 millimeter displaced temporally in each eye. So what's going on here? Well, my student rightly pointed out that if we are experiencing true lateral decentration, this needs to be adjusted before lens wear can continue. Having a well-centered lens is the most important fitting consideration at the initial follow-up visit. But with true temporal decentration, we would expect poor vision, which this patient did not have, and also high astigmatism when we measured with autorefraction because of the displacement of the lenses interfering with the area that we're collecting our refraction measure. And again, that wasn't the case for this patient. In order to adjust for true lateral decentration, you have two options. You can either increase the sagittal depth of the lens or increase the lens diameter. But this patient seemed to be displaying more of what we're terming pseudo-decentration, where vision is often very good, you're getting minimal refractive error, and this actually doesn't require any lens adjustment. So what is pseudo-decentration? Well, especially in our young patients, there is this interesting anatomical phenomenon where the visual axis, represented here as the line passing through the point of fixation and the patient's fovea, doesn't match the pupillary axis, which is the line that bisects the pupil to the retina. And the difference between these two axes is angle kappa. So when patients are fixating on the center green dot, the image may be decentered if the patient has a large angle kappa. So to adjust for this, instead of asking the patient to look at the center dot, we actually advise them to look 1 to 2 rings nasally. So if this were their left eye, we'd have them look 2 rings to the right. And as you're watching the screen, you'll see the reflection of the Myers shift toward the center of the pupil. And this is a great way to adjust for these angle kappa deviations. So when we do that, we had this patient look 2 rings nasally. And now we see a fitting pattern that's much more in line with what we experienced from this patient's exam. So this now looks to be a very well-centered lens. So these adjustments can be really helpful as you're trying to troubleshoot fits. And I recommend marking down exactly which ring you have them look at so that you can be consistent as you move forward in the fitting process. So that's case 1. In case 2, we have another initial fit. Again, a low myope with a low amount of width of roll corneal toricity, and represented both, again, in terms of the refraction as well as in the keratometry. So this is the initial topography that was presented to me again by my student. So we're looking at baseline images, so they have them in axial power format. And If you were to, at first glance, look at these images, it's not clear that there's much astigmatism really present, despite having observed that with the refraction and with the keratometry values. And remember that keratometry is just going to be measuring the central, usually 2 to 3 millimeters, depending on your device. So looking at this, it's kind of hard to judge the extent of the astigmatism and the magnitude. So what I recommended that they do is go ahead and adjust this color scale. And I always advise my students to make the best use of the tools that we have. So by making this closer to a normalized color scale, we can actually now appreciate that this patient displays a moderate amount of full limbus to limbus corneal toricity. And this is really important because if we think about where a lens is going to land on this cornea, usually around the 6 to 8 millimeter mark, then this patient clearly needs a bitoric lens design. And that's not something that we would have been able to appreciate from just the refraction and keratometry information alone. Remember, they had a really low amount of astigmatism, but the fact that it extends this far is really critical for their fitting success. And just to contrast this, here's another patient with a nearly identical refractive error, but by really making use of these topography color scales that are available, we can see that this patient's cornea it has a more concentrated, localized astigmatism at the center. And so when we're measuring refraction, we're measuring just this area, we see they're nearly identical. But when we think about where the lens is going to land in this outer ring, we can see that these patients clearly need a very different lens design. All right, so I hope that those couple of tips were helpful for you. I'd love to continue this conversation as the meeting moves forward. Thank you so much for your time and attention and the invitation to be here today.
Thanks a lot to Asia Pacific Myopia Society Academy. Nice meeting you all online. I'm Dr. Lu Fang from Eye Hospital, Wenzhou Medical University, where we have established an education project and eye hospital group. Through many years' efforts, we have grown up into one of leading institutes in eye and vision higher education, clinic, research, and research translation. Before talk, I'd like to extend to appreciation to our research teams and the innovation work in the myopia field. Most of this research are supported by these fundings, and most data I quoted in my talk are from our team's work. Myopia control project has been put on our first page in China. We have a big team measuring in myopia studies for a dozen years in 3 ways. One, an epidemic study in Wenzhou City, covering 99% whole student population in Wenzhou City. Our research data gives a large contribution to what the National Myopia Control Project and put the focus exactly on the adolescents. 2, a lab-based study series about retina, choroidal, and scleral, forming a theory of scleral hypoxia, which gave some scientific support to the outdoor activities and less reading work for myopia control. And 3, and a series of clinical studies in myopia correction and control effects around the spectacle design, around the special design spectacles, multi-focal soft lenses, and orthokeratology lenses. Most clinical research around its myopia slowdown effects, their direct effects, their combined effects, their mechanism, and the solution to the clinical problems. So far, the clinical fitting are going well, including their safety and clinical fitting quality. And clinical outcomes varies, and the building up experience and the open sharing are very valuable for our clinical work. Among the clinical collection for myopia case, the fastest growing is the orthokeratology in past years, about 35% annual increase in average. The reason goes to the huge adolescent myopia population, and the National Myopia Project makes more people knowing the lens and its benefits. Fortunately, the orthokeratology booming did not make the professional or business in a mess. Contrary, the current situation is stable, rational, and certainty because of several reasons. One, each part related to orthokeratology, including lens manufacturer, fitters, government agency, and marketing business, is all working carefully on its quality and safety control to protect it from any harms. Two, very well-trained professional teams are on the first line, highlight its characteristics of professional. And three, consensus on its high standard, both from fitting and wearing. Here, I listed the 9 brand products in China. I believe the growth brought them not only the market share, but also the responsibility. And that's true. The whole related system is in open talk and the connection. And these are the base for the healthy running of orthokeratology. We were honored to be selected as the China National Clinical Research Center of Ocular Disease. And this is our mission and purpose. And in the clinical study section, orthokeratology is one of the important chapters in the clinical study plan. Meanwhile, we also constructed a multi-layer central system led by the National Clinical Research Center, and branch centers are built at different processes, followed by qualified research units to consist a multi-center research system. And this is the huge supporting system at the bottom. The National Research Center has its internal working frame. Around the orthokeratology, we work together on its clinical study, experts consensus, professional training, and science popularization. One of the clinical study site is in Boao, where the National Special Medical Zone with special priority policy for new medical products or therapies application. We are taking care for this in ophthalmology and optometry, and these include new designed contact lenses. The value of special medical zone is reflected in two. One, we can directly use the new products which have been approved in other countries. Two, the clinical application simultaneously will be included as a real-world study in the first place. And these outcomes will enhance the future official approval of these products or therapies. In our headquarters eye hospital at Wenzhou, we have a big team and a big space for orthokeratology clinics and their clinical studies. We can see here from the research projects about orthokeratology, the driving power came from hospital internal, patients demanding, lens or care products industries, and research foundation. We keep all the wearers for follow-up visits through informed consents. Here is a general information. We can tell from the slides that the wearers moved to younger kids for myopia control purpose. The National Myopia Control Project helps a lot to the students' population through screening programs and science information access. The compliance is very high, and the control effects are reasonable to what we found from designed study. The designed research is either funded or research initiated, most around mechanism of slow down myopia progression from optical approaches or from bioresponses approaches. On the other hand, AI-involved researchers for smart app or programs are very active, with goals to make clinical work more efficient or accurate. Because of theory from lab-based study on myopia control that was completed mostly in the research center, there are several teams did a lot about the orthokeratology, the slowdown effects, and the colloidal responses. Shanghai team, Zhongshan team, and the Wenzhou team, they all gave very equivalent findings. They all prove true the colloidal thicker and the vessels more active with slowing down effects. In addition to the study on ocular imaging versus slowdown effects, some of research teams are very interested in developing programs helping clinical fitting. These research teams from our academy used to work with external engineers, and the research teams from industries have their own teams on this. I personally very supportive to the cooperation of clinical specialists and the AI engineers. These researchers also initiated cooperations among multi-centers, as well as the sharing of outcomes. With these research outcomes, the clinical fitting learning curve becomes very steeper, and safety become top priority, and the fitting become more efficiency and much easier. In clinical work, and the researchers keep us update of the orthokeratology fitting. We summarized them as an expert consensus for colleagues to share and to follow. We published several consensus. Each has its own focus, and each has updated its previous versions. For example, the recent version was emphasized on the standard flow and its essential phrases. It gives much clearer and straightforward about facility, patient education, and a pattern evaluation. The follow-up plan was double reminded at the points for the patients. And we set up a series training programs open to fitters. We included some of the training into medical continuing education credits. Training activities among subclinic aliens members, Myopia Control Academy. With the time, we built up very rich resources for such kind of training, including differently levels design, dry or wet classes, online and online lectures or practice classes. For example, this year so far, we have conducted 9 on-site classes around the country. More than 1,000 learners take part in the classes. Meanwhile, we are empowered to deliver lectures for public education on myopia control We found wherever we went, schools, communities, or public media, most of the questions were about orthokeratology. We spent a lot of efforts to develop a very big speak teams among all aligned member institutes. We have conducted more than 3,000 lectures to public in last 2 years. In summary, national myopia control projects in China unintentionally promotes orthokeratology business. Active myopia researchers and open information make the public awareness the benefit and the limits of orthokeratology. And professional fitting and rigorous management are very important for keeping orthokeratology in China stable, safe, and effective. Among 3 clinical collections, glasses, soft lenses, and orthokeratology lenses for myopia control, orthokeratology lenses is still the one can be chosen by many myopia kids. Think about the myopia situation among the kids. Think about the mechanisms that are unknown to us. So the research has a far way to go. Thank you very much for your attention. Thank you.
Thank you. Thank you. Yeah, it's time for open discussion. Because I heard from the Professor Zheng's talk, the orthokeratology in China almost account 90% of the world. So that's a very amazing number. So I feel it's a very concerning that how to keep the orthokeratology business and the clinic be safe, effective, and sustainable.
Yes, I think 90% is due to the high myopia in China, and also the OrthoK look like in the Western countries not paid by government; they pay themselves. So I think it's this limitation. I think I'm not sure because total news in US probably should know better. I asked I asked some American OD. They said the kids they want to wear the OK lens, but it's too expensive. So,
yeah. Does Liu Yue has more information about that, like orthokeratology business and the clinics in United States or European countries?
So it's certainly rapidly growing, but probably not as dramatic as it is in China. And the fee modality charged in US is slightly different. OrthoK service is in general divided into the feeding service, basically charging for the clinician's chair time and their expertise, and the material cost, which is the charge for the lenses. And so for the second year, because we're not spending nearly as much chair time, the feeding fee is much lower. And so in comparing to the overall cost in China, the OrthoK feeding overall package is actually cheaper starting from the second year and forward. So this is actually my question back to you, Professor Liu Fan. And to be able to address myopia as a public health concern, do you see what it would be the primary line of control method in China to address myopia from a populational level? Probably we all agree it's not going to be OrthoK, considering it's
definitely not
resources.
Because we thought, because especially the whole country online education happened last year, 2020, almost half year, and the myopia incidences just very rapidly, dramatically increased to 11%. So it tells us that education and very heavy learning or very early age of short distance and many hours focus on books are the very powerful reason for young kids myopia. So we're always kidding that the top reason of the young kids myopia come from the Ministry of Education. So this is what we are. So from our epidemiology study among our cities, so we feel the most important strategy for myopia control is more hours outdoor activities and less learning hour. So we need study much earlier. Should be in primary school, especially the among the kids who haven't have the myopia, and even earlier. So this is what we are doing, including the public education. So definitely, also keratoconity is like have to, not necessary.
I also have a question for both Professors Zheng and Liu. So apparently, to be able to evaluate the efficacy of OrthoK lenses over time and to avoid having unnecessary washout from the treatment, we need to monitor the change of axial length. But apparently, without knowing their previous rate of axial length elongation, it's hard to actually quantify how much we're able to slow it down. So do you consider it's possible in the future that we incorporate axial length measurement as a standard practice in very young age children, like as early as they can cooperate in this test? Do you think this is possible?
Yeah.
Yes.
Okay.
Yeah,
please.
Okay, I think it's possible because during the clinical procedure, we also usually measure the axial length each time. So it's very popular in our clinic. The ocular axial length and the reflection is necessary in each time. So I think it's no problem. Yeah.
Yeah. Yes. Yeah. In our recent expert consensus, we included the axial length measurement as a necessary part of also keratology clinic work.
Yeah. So I guess the concern is more about whether we can capture those data, especially like large data, before they become nearsighted. A longitudinal study from Singapore, which is published in 2019, had shown that in Singaporean school children, the axial length elongation actually preceded the clinical onset of myopia by about 2 years. So which means 2 years before children become nearsighted, they started having this accelerated axial growth. So in the future, would that be considered as a part of the standard exam for children's school screening instead of when they're interested in OrthoK treatment?
Yeah, I think it's according to that base, it's very important. But currently, because our myopia control project resource supported to do the screening, we need to consider the sustainable. So currently, we only not each screening included the axial lenses, but we only encourage the city or some districts who have adequate financial support. But based on their study, we feel it will be we should popularize those measures. Yeah, with the big data, we might have more information from that. If big data can tell the same story, that will become like a foreteller. That will be very important for our future work.
I have one question. Ask Dr. Liu and Dr. Liu. In my clinic, many kid parents, they said that it's possible to wear contact lens age under 8. Is in the US is okay, or in Wenzhou is okay. Currently, I use OrthoK above 7.
So let me start first. In US, OrthoK approval doesn't have a lower bound of age limit. So we consider 3 factors when deciding whether ideal candidate for OrthoK treatment. Number 1 is the child's motivation in wearing OrthoK lenses. Number 2 is their independent ability to at least remove the lenses. Ideally, we want the kids to be able to both insert and remove the lenses without the help from parents. Number 3 is their maturity in reporting back to the parents when there is a concern or a problem. And in those kind of a judgment, the maturity of the kid is a better, a more predictable indicator than the physical age. So we have like a 4 or 5 years old children who are able to handle the lenses pretty efficiently, but we also have 18 years old patient having their parents taking care of the lenses. So to answer your question, I think it's possible, but it's very case by case.
Yes. Also, I want to ask Dr. Liu, is any other procedure if OrthoK still cannot control the myopia very well? Is any OrthoK plus atropine or SOK plus optical lens something?
So at this point, we're all waiting for more clinical trials and confirming the synergistic effect between OrthoK or any optical treatment combined with low-dose atropine. And if low-dose atropine is creating some additive effect, well, what is the exact mechanism for that synergy? Is it because atropine dilate pupils slightly, which potentiate the optical impulse defocus of both OrthoK lenses or multifocal lenses on the retina, or it's because both atropine and optical treatments are working in the posterior structure through different pathways. But at this point, it's becoming more and more popular to combine low-dose atropine with one of the optical treatments to enhance or maximize the efficacy. Beyond that, I'm not seeing any other newer development in the combination treatment. Dr. Lam, you're on mute.
Yes, I would like to ask a question about the toric OK lenses because, you know, a fair amount of the patient may have some degree of astigmatism. So what's the design concept? And also, will there be any sort of quick development in future? At the moment, usually, well, most of the lenses, they are able to take care of up to 1.5 or 2 diopters. Will there be a chance that we are able to take care of higher degree of astigmatism?
So in terms of the toric or dual axis lens design, the design principle at the current stage is to have the lenses in the mid-periphery matching or conforming to the toric cornea as best as possible so that the weight bearing of the lens is as even as possible, 360 degrees. That's the best way to achieve long-term centration of the lenses. I know there are several labs who are actually designing a toric optics, meaning not only the peripheral of the lenses are toric, but the base curve or the optic zone of the lens is also toric. So they're trying to create some asymmetric corneal molding in achieving a truly astigmatic correction. So this is still under development, which obviously require the lens not only to be ideally centered, but also does not have much rotation or oscillation in terms of the fitting. And if that's the case, truly correcting astigmatism on top of correcting myopia would be possible. Whether that talks to a better efficiency in myopia control, that part we don't know yet.
Thank you.
Thank you. Time's up. It seems very nice meeting you all. Thank you. Bye-bye. Take care.
So the Symposium 7 next session, the title is The Prevention of Myopia.